Hi, this is Alex from devstories.eu. PySpark Fundamentals, episode 20 of 21. Your PySpark job is not slow because it is computing data. It is slow because it is spending all its time moving data across the network. When a simple join brings your cluster to a crawl, the solution lies in bug busting, physical plans, and joins. When you write a PySpark script, you define logical operations. You tell Spark what you want, not how to do it. But when a job underperforms, you need to know exactly how Spark executed your request. You do this by calling the explain method on your data frame. Calling explain prints the physical plan. This is the blueprint of actual tasks Spark runs on your cluster. You read this plan from the bottom up, tracing the data from the source files all the way to the final output. If you look at the physical plan for a standard join between two data frames, you will likely see a step called sort merge join. To perform a sort merge join, Spark must ensure that rows with the same join keys are physically located on the same executor. To achieve this, Spark performs an exchange. Exchange is the physical plan term for a network shuffle. It means Spark is ripping data out of partitions, pushing it across the network, and writing it to disk so the other executors can read it. Shuffling is the single most expensive operation in distributed computing. Here is the key insight. If you were joining a massive fact table to a small lookup table, shuffling the large table is a massive waste of resources. Instead of shuffling both tables to align the keys, you can just send the entire small table to every executor. This is done using the broadcast function from the PySpark SQL functions module. When you call your join method, you simply wrap the smaller data frame in the broadcast function. By wrapping the small table, you give Spark a strict directive. Spark will collect the small data frame to the driver node and then transmit a complete copy of it to the memory of every single executor. Now, when the large data frame is processed, the executors already have all the lookup data they need right there in RAM. They just stream through their existing partitions and match the rows locally. No sorting is needed, and no data from the large table moves across the network. If you call explain on this new broadcasted join, the physical plan looks completely different. The sort merge join is gone. The expensive exchange step is completely absent. In their place, you will see a broadcast exchange and a broadcast hash join. The broadcast exchange just moves the small table once, and the join itself happens entirely in place. The easiest way to double the speed of a Spark job is to stop moving data that does not need to move. Read your physical plans, spot the network exchanges, and broadcast your small tables. That's it for today. Thanks for listening. Go build something cool.